So for 5-5, we are just going to focus on inequalities of the triangle. We're not going to be doing the indirect proof. Okay, so we're not going to be doing that part of it. All right, so in both of these, the hypothesis is going to tell you about the two sides of the triangle. If they're not congruent, something happens. The first one tells you that the larger angle is opposite the longer side. And the second one tells you that you're going to have the longer side opposite the larger angle. So in both of these theorems, they are reminding you of your isosceles triangle theorem. Remember in the isosceles triangle theorem, if you have an isosceles triangle, because the triangle has two congruent sides, what do we know about the angles? There's going to be two congruent angles, so two angles are the same. This is similar in that it tells you if AB is the longer side, okay, so if AB, the length of AB, if that is greater than or larger than BC, then the measure of angle C is greater than the measure of angle A. The significance of angle C is that it is the angle across from AB. So because this side is bigger, the angle across from it's bigger. So let's color code the other one. So for BC, which is this side, the angle across from that is angle A. So this is the angle across from BC. And then this is the same thing, but in reverse. So they're telling you which angle is greater. So if you know that angle Z is greater than the measure of angle Y, then that means XY, which is the side across from the angle. So this is the side across from angle Z. Okay, we know that that's going to be larger than XZ because XZ is the side across from angle Y. Okay, so in short, whichever angle is bigger, the side across from it will be bigger. Okay, whichever side is longer, the angle across from it will be larger. So that's how those relationships work. So now when we go to our first example, we have to write the angles in order from smallest to largest. So because we're writing the angles in order from smallest to largest, but all we have are the sides, all we have to do is find the smallest side. All right, so if I'm looking at my three sides, the smallest side is going to be 17.2. Okay, so you have to look at your numbers. 17.2 is the smallest. So because this is the smallest side, angle F is across from it, so this will be the smallest angle. Okay, so from smallest to largest, I'm going to put angle F first. So the next thing I would want to do is find the largest angle. So if I'm finding the largest angle, I just have to find the largest side. So out of these three, this is the largest side. So the angle that is across from that is angle G. So I'm going to leave a space because angle G is going to be the largest angle. Now, you can always tell which one is across from it because it's the only side not touching that angle. All right, and then that leaves, of course, angle H. So angle F, angle H, angle G. part B is very similar, but now you are looking at the sides. And the sides you are writing from shortest to longest. So to find the shortest side, we have to find the shortest angle, but we're only given 2 angles. Luckily, we know every triangle is 180 degrees, so if I want to find that missing angle, all I have to do is subtract 60 and 72. And then I can figure out that this missing angle here is 48 degrees. Now that I have all of my angle measures, it's very simple for me to determine which one is the smallest. And that one, of course, is going to be angle R. Okay, so if this is the smallest angle, the smallest side will be directly across from it. So what I'm going to look for is the side that is not touching that angle. So in this case, it's PQ. Now the largest side is going to be across from the largest angle, and our largest angle here is what? Angle Q. So angle Q is across from PR. So this is going to be the longest side.
How'd you get an 8 at the bottom?
Say it again.
How'd you get an 8 at the bottom when you subtracted it?
Oh, the 48?
Yeah.
Yeah, so it's like you're borrowing. You can think, like, so 180 minus 60 is going to be 120. 120 minus 72, you'd have to borrow. So 10 minus 2 would be 8. When you borrow, this would be 11. 11 minus 4. Or 11 minus 7 is 4. Yep. Okay, so then my longest side is going to be PR, which would go right here. And then I just have to find the other side I haven't named yet. Okay, so you have PQ. Okay, you have PR. The only one you don't have is QR. Good. And if you called it RQ, that's fine as well. Okay, so to summarize the first page, the largest angle is across from the largest side. The smallest angle is across from the shortest side. Yep. All right, now on page 2, we have another theorem. I'm going to read through the theorem with you, but then we're going to write it in our own words. So the triangle inequality theorem says the sum of any 2 side lengths of a triangle is greater than the third side length. So the sum of any 2 side lengths has to be greater than the third side length. So all that means is you should be able to add any 2 sides together, and it has to be bigger than the third side. If it's not, then it's not a triangle. Okay? So if you add any 2 sides of a triangle, that value is greater than the length of the third side. So a triangle has 3 sides. You should be able to take any 2 of those sides, add them up, and it will be greater than the third. Again, if that doesn't happen, it's not going to be a triangle. So, for example 3, when they ask whether it can have these sides, what we have to ask ourselves is, are any 2 sides added together longer than the third side? So then we just want to test that out. So I can add any 2 of those sides together and make sure that it's greater than the third one. Now I would take the 7 and 10 first, because 7 and 10 are the shortest lengths. So if I add 7 plus 10, 7 and 10, and you guys can draw a picture of this. Sometimes I feel like that helps. It doesn't matter if your picture is drawn to scale or not. It's just kind of nice to see where you're comparing. So if you add 7 and 10, it should be larger than the third side, which is 19. Well, if you add 7 and 10, what do you get? Okay, is that larger than 19? No. So then what we do is we put a slash through it, and then this is not true, right? So 17 is not bigger than 19. So what we would say is no, by the triangle inequality theorem, a triangle cannot have these side lengths because 7 plus 10 is not greater than 19. Okay, so it says tell whether it can and then explain. So your explanation would be no by the triangle inequality theorem. A triangle cannot have these side lengths because if you add 7 and 10, that's not greater than 19. Okay, so it doesn't matter that if you added any of the other two together because you've already found one that's not true. If you do find that one is true, you have to keep going until you've checked them all. So for B, we can choose any two sides. Like I said, you can add the two shortest ones together first. So 2 plus 3 plus 3.1 would have to be greater than 4.6. Oh, and feel free to draw your triangle too if you want. And like I said, it can be any triangle. So even if it's not drawn to scale, sometimes it just helps to see what you've added together and what you have not added together. So if I add 2.3 plus 3.1, I'm going to get 5.4. Is that greater than 4.6?
Yes.
Yes, so then I just put a check. So now I'm going to choose two other sides. Again, doesn't matter what two other sides you choose. I'm just going to do 3.1 and 4.6 next. And then I have to verify that that's greater than 2.3. Now, right away, we're going to know it is because what do we know about both of those lengths? Yeah, both of them separately are bigger, so then obviously both of them added together are going to be larger as well. And then the same thing's going to happen for the, well, not the exact same thing, but your 2.3 plus 4.6, you know is going to be bigger than 3.1 because 4.6 is already bigger than 3.1. And you will never have a negative side length. Okay, so really, I would always start with the shortest side lengths and add those together before I did any of the other ones. All right, so now that we know that this works, we would say yes, because the sum of each pair of side lengths is greater than the third. There, I said this third length. Yes. That. Oh, good question. So if it's equal, then it would not be true. Okay, that's a really good question. So because it is just greater than and not greater than equal to, if they were both the same, it still could not be a triangle. All right, and that's something we'll also talk about briefly in example 4. So in example 4, you are given two sides of the triangle, and they're 8 inches and 13 inches. What you have to do is find the range of possible lengths for the third side. Okay, so a range is not a single value. It is many values. When you are finding your range, you are using an inequality. Okay, so the range is going to be an inequality. You're not going to have an equal to in it. And then I'm just going to write out the directions for you, how you're going to find it. Okay, so to find the range, there are two parts of the range. There's the upper bound, there's the lower bound. So to find the top value, of the range, you need to add the two sides. Okay, now I said there's also a bottom value. So to get the lower value, and you could probably predict what I'm going to say, to find the lower value of the range, you need to, subtract. You need to subtract the two sides. Now, when you are subtracting, you always want to take the larger one and then subtract the lower one, because you're never going to have a negative side length. All right, so let's do this. If we find the lower value, we're going to have to take 13 and subtract 8, which would give us 5. Yep. And then if we add them together, 13 plus 8 would be 21. So this is how you're going to write the range. I'm going to show you, and then I'll give you like a general form that you'll always write it in. So what you're trying to say is that the sides have to be between these two values. The way we say that with symbols is 5 is less than x, which is less than 21. That would be your inequality. So what this means is the third side length has to be greater than 5 and less than 21. Now the fact that it's greater than and not greater than equal to is really important, because if it was greater than equal to, that means it could be 5. This has to be greater than 5. So any value greater than 5 would work, but 5 would not. If you plug in 5, then they'd be equal. And like we just talked about in the last one, if they're equal, it's not going to satisfy your condition. So, like I said, I'm going to give you just a general rule to write. So make sure you use less than signs and not less than equal to. Here's going to be the general setup, so you can really always use this as your setup. It's going to be a value is less than x, which is less than another value. And this would be your top value. This would be your lower value. Okay, so the top value, you add to get that, subtract to get lower. All right, so your homework, I'm going to have you write this down so that if you finish with your quiz early, you can get started on that. That's it. Okay, and then I'm going to go over your answers to your quiz to your review